So we're looking at oxidation and reduction here, 7.1. This is actually a physical chemistry topic, but it's used in a lot of inorganic chemistry. So you've got to know about oxidation and reduction to do a lot of inorganic chemistry topics. That's why we're looking at this now. Let's write down an equation. What we're doing here is we're adding oxygen to copper to make copper oxide. The oxygen is added to copper to make copper oxide. Therefore, we say that the oxygen is the oxidizing agent. And this process, of course, is oxidation. Let's have a look at another equation. Still involving copper oxide, but this time copper oxide is a reactant. What we've got here is we've got copper oxide as a reactant and copper as a product. So I've removed the oxygen from the reactant to give the product. The removal of oxygen is called reduction. So this equation here is reduction. The copper oxide has been reduced. Therefore, the thing which does the reducing is a reducing agent. So the hydrogen here is the reducing agent. So we've got oxidation, the addition of oxygen, reduction is the removal of oxygen. Often we find that when hydrogen reacts with something and remove oxygen, hydrogen is the reducing agent. Okay, let's have a look at this one then. So, what we can see here is an equation which doesn't involve oxygen at all. However, I can tell you that this reaction is actually a reduction reaction. Remember, a reduction reaction, in terms of this equation here, was the removal of oxygen. This is also a reduction reaction, however there's no oxygen in here, but it's still classed as a reduction reaction. And we're going to be looking at why that is in this lesson. Okay, let's go back to our original equation here. I'm going to write it out again. Copper plus oxygen makes copper oxide. So copper oxide is an ionic compound. We know it's an ionic compound because copper is a metal and oxygen is a non-metal. So these are ions which are electrostatically attracted to each other. We know oxygen is in group 6 of the periodic table. Therefore it needs 2 more electrons for a full shell. So this equation can be rewritten like this. With O2 minus here, like that. Now, because oxygen has a 2 minus charge, then the copper must have a 2 plus charge. So this equation here and this equation here are relatively the same thing. Then we can have a look at just what happens to the copper. So we can ignore the oxygen and just focus our attention on the copper. We'll go from a Cu atom to a Cu2 plus ion. So let's have a look at that process. Okay, to go from a Cu atom to a Cu2 plus ion, what I've got to do is I've got to remove 2 electrons from the atom to give an ion. So I'll write down plus 2E minus. And plus 2E minus means 2 electrons. So what I've done is I've removed 2 electrons here. 2 electrons have been removed. This is what we call a half equation, because I've only shown what happens to the copper. Let's write down the other half equation. So it's with this bit and this bit in it. So I've got a half O2, so that's essentially one oxygen atom. Makes an O2 minus ion. We have a 2 minus charge on this side of the equation. Therefore I need a 2 minus charge on this side of the equation. So I need to gain 2 electrons here. So I add 2 electrons instead. So 2 electrons have been gained. This is the other half equation. So this is the first half equation. This is the other half equation. And you know that 2 halves make a whole. So the 2 halves will make the whole equation. Notice if we add the 2 half equations together, you end up with the original equation. Let's just try doing that now. So we can add these 2 half equations together just to get the original equation. Just so the process going backwards. So to start off with, we've got Cu and a half O2 and 2 electrons. So we write Cu plus a half O2 plus 2 electrons. That makes Cu2 plus O2 minus and 2 electrons again. Notice that there's 2 electrons here and 2 electrons here, so they can cancel. All I've done really is transferred the electrons. Let's go back to this original 2 half equations here. What's happened is the copper has given these 2 electrons to the O2 here. The copper has given those 2 electrons to the O2. So the Cu has given 2 electrons to the half O2. Let's write down a mnemonic here. So let's write down the words oil rig. Now you might have seen the word oil rig before at GCSE. It stands for oxidation is loss of electrons, reduction is gain of electrons. Okay, the Cu has given 2 electrons to O2. If the Cu has given 2 electrons, it means it's lost electrons. We can see here that 2 electrons have been removed. So Cu has given 2 electrons to the O2 minus. Also, the O2 minus has gained 2 electrons. So we can go back to our original equation to work out what's happened in terms of oxidation and reduction. Remember, oxidation is loss of electrons. Let's have a look to see what's lost electrons. The Cu here has lost electrons. So the Cu has been oxidized. Now let's have a look to see what's gained the electrons. The O2 here has gained the electrons. Reduction is gain of electrons. Therefore, the O2 has been reduced. Okay, that's our first example. Let's look at another one. So this is an example where copper oxide reacts with magnesium. Now when copper oxide reacts with magnesium, you get magnesium oxide and copper. You might remember from GCSE the reason why that happens. The reason why that happens is because magnesium is more reactive than copper. Therefore, the magnesium is able to displace the copper from the copper oxide. So that's the magnesium is more reactive than the copper. That's why that reaction works. So we can write down the equation in a different way. We can write it down like this. We know that CuO is an ionic compound. So that's a Cu2 plus and an O2 minus. This is a magnesium atom here, remember. This is not an ion. We've got an ionic compound here. So we have an Mg2 plus and an O2 minus. And again here, this is not an ion, so it has no overall charge. First of all, let's cancel out something which has stayed the same. Let's look at the things which haven't stayed the same first. Well, the copper hasn't stayed the same because it goes from Cu2 plus to no charge. The magnesium hasn't stayed the same because it goes from magnesium to magnesium 2 plus. However, the oxygen stays O2 minus in the reactant and the products. Therefore, it stays the same. So we say it is what we call a spectator ion. The spectator ion just spectates what's going on and doesn't react itself. So I can cancel that like this. So the reaction becomes that's what we'll call the ionic equation. So the ionic equation shows what's happening to the ions which change. What we'd like to do now is we'd like to split that ionic equation into two half equations. Let's look at the first half equation. Let's pick the copper here. The copper goes from Cu2 plus to Cu here. In doing that, we have to neutralise that positive charge by adding 2 electrons. So we add 2 electrons. Let's have a look back. This oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So I've gained electrons here. So we write down that the CuO, because that's where it's from, the CuO is reduced. Let's look at the other half equation here. We'll start off with Mg, we end up with Mg2 plus. To do that, I need to remove electrons from the Mg. Oxidation is loss of electrons, but reduction is gain of electrons. So what I've done here is I've lost electrons. So we say that the Mg is oxidized. Okay, now let's have a look at what has actually made the Mg oxidized. Well, the thing which does the oxidizing is actually the species which is being reduced. So the Mg is oxidized, the oxidizing agent, which is the species which does the oxidizing, is the CuO. So CuO is the oxidizing agent. We can do exactly the same thing to the first half equation. We know that the CuO is reduced because it gains electrons. We need to know what's giving the electrons to Cu2+. Well, it must be the thing which has been oxidized. So here we produce not electrons. Those electrons here are given to the Cu2+. Therefore, the CuO is reduced and the Mg is the reducing agent, the magnesium. Just to recap that, the CuO is reduced, the Mg is the reducing agent, the CuO is the oxidizing agent, and the Mg is oxidized. So in summary, we can write down a rule, and the rule is that the oxidizing agent gets reduced and the reducing agent gets oxidized. Okay, let's write down another equation here. So we've got calcium plus bromine makes calcium bromide. So this is an ionic compound, so that can be split up into its individual ions. So we've got Ca2+. Remember, bromine is in group 7 of the periodic table, so it must be Br- and not 2-. We need 2 of those though to balance the charge on the 2+. So we write 2 Br-. So that's 2 times Br-. So this is our overall equation. We can split that overall equation into 2 half equations. Let's look at the calcium first. Here's our first half equation. So what I've got here is I'm losing electrons. Oxidation is loss of electrons, oil. Now remember, the reducing agent always gets oxidized. So the Ca is oxidized, and it also must be the reducing agent. Let's have a look at the bromine now. Br2 to 2 Br-. Reduction is gain of electrons, so the Br2 has been reduced. Remember, the oxidizing agent gets reduced. Okay, just to summarise, we've defined oxidation and reduction as the addition and removal of oxygen. We've also defined oxidation and reduction as the addition and removal of electrons. We've introduced half equations, and we've used those half equations to identify what has been oxidized, identify what has been reduced, and identify the reducing agent and the oxidizing agent.